Welcome back. In the previous lecture, we discussed about the Kafka high-level architecture. We saw producers sending the data to the Kafka and consumers are reading the data from the Kafka. So Kafka itself a cluster which is having multiple brokers, right? Though we have gone through those things and we understand that Kafka is a distributed, scalable and fault-tolerant system that sits between the middle and between the producer and consumers. But still we haven't got the answer of the some fundamental questions, right? What are these fundamental questions? First is how this message is stored where? When producer is sending some message, where this message goes and inside the cluster where it gets stored. How it is stored, how does Kafka scale, how does it maintain the ordering? So there are many questions, right? Let me write some points. Ordering, how this gets scaled, okay, and actually how data is stored, right? So these are the basic questions, and you'll get the answer only when you are going to deep dive in the cluster. Okay. So before that, there are multiple things that we have to learn. So two of them are a very basic one, that is topic and partition. Okay. So first we will understand the topic deeply, and then we will move to the partitions. Okay. So let's discuss the topic first. So what is the topic? So if I say topic is the most basic level in Kafka, and it is nothing but it's a logical stream of record. Logical stream of record. So just you can understand, it's a category under which events are published. It's a logical system. There is nothing like physically some topic is there. No, it's just a logical grouping of messages based on the category. So like if I take one e-commerce example, you might have heard like ordering, order service is there, okay, payment service is there, shipment service is there, okay. There are many services, right? Each service is going to produce some kind of events. So each service send their events in some logical channel, I say. So like ordering events is coming in the order topic. In the same way, payment events are coming in the payment topic. In the same way, shipment is coming in the shipment topic, right? So each of these is a topic. So when the order service creates order, it went to the order topic. When payment service complete the payment, it published the event to the payment topic. So at the surface level, topic help us to organize events by the business domain. Understood this? All these topics are having a same kind of events which is generated by a specific domain or a specific service, right? So let me give you an analogy of that. You might have heard any news channel, right? What does this news channel? They are having multiple category: sports, news, some other like business, or some music. Okay, so these are the channel. If you are subscribed to sports or you are subscribed to business news, then whenever any event is happening in this category, the subscriber they will come to know about those events. Okay, so viewers subscribe to this channel, they are interested in, they are going to receive the broadcast or content. So topic is almost same. This is same as topic. Consider this channel as a topic. The only difference is that once 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 the show is airs, it's gone. Once show is live and finished, it's gone. But not, this is not the case in the case of Kafka. But Kafka says event will remain same, event will remain stored, for replay, reuse. But of course this is not going to work for lifetime. It is configured with some time, some configuration file will be there. We have to configure this time. So how much what is the duration of this is message going to be stored? That duration we used to configure here, duration. Okay, as I told you, topic is a logical entity. Okay, it's a logical entity. What does it mean? So it means a topic is not where data is physically stored. A topic is a logical abstraction. Internally, Kafka does not create one giant file based on some topic name. If suppose order topic is there, it doesn't mean that we are going to create one very big file going to give the name of order topic and all the events I'm going to store here. No, this is wrong. It's not physical storage, it's not a physical file. So instead of that, a topic is divided into multiple partitions. So a topic is a logical, but partition is physical. Now each topic is having some partitions like P0, P1, P2. So these partitions are physical, physical entity, but this topic is logical segregation, right, of the messages. Okay, so when we create any topic, we are going to have some configuration. So when you create topic, you are going to give some number, some configuration parameter like number of partitions, okay, replication factor. Remember, this is very important concepts. Third one is retention period. And some other things are there like cleanup policy. And the last one was segment size. This is also important part. So this much information you have to pass when you are going to create one topic. Okay. So now this configuration is going to impact the way a partition behave inside a cluster. Okay. So if I take one example to just to make you understand, suppose I'm going to create one topic. I give the name of topic is like order. Okay. And partition I have given suppose 6, and replication factor normally we give 3, and retention period suppose 1 week, it is 7 days. Okay, so what I call it, Kafka then create the 6 partition log across all the brokers. So you know that cluster is nothing but a group of brokers. Each brokers is going to have this partitions because topic is inside the broker. Topic is a logical entity. So it's not going to store anything anywhere. So ultimately the partitions which are going to reside on the brokers. Okay. So the topic itself become a metadata definition that tells Kafka how to manage its partition. Okay. So topic, at the topic level we might have some some metadata informations which is going to tell Kafka like how to manage its partition, maybe some replication factor, maybe some other values. Okay, we'll see that. Now let's understand what are this concept that he came across, that is topic retention, right? What is topic retention? So we have till now we have seen topic configurations. So we have find out like these are the parameters which are required, and then we come to now topic retention. Let's see that. So topic retention. So it's a very powerful feature. So one of the Kafka strongest architectural decision is retention. Message in a topic are not deleted immediately after consumption. They remain in the Kafka for a configured retention period that I told you, like 7 days we have taken previously, remember? Like this one. So the data will be data will be stored over there for the next 7 days, though it is consumed multiple times. So that going to be remain for a given period of time. So this is going to enable multiple things. First, replay of the historical data. Recovery from the consumer crashes. Recovery means suppose you are consuming some messages and at the same time your consumer got crashed. So when the new consumer will come up, it has to be start from where the previously consumer died, right? So that particular location in the message stream we have to identify. So this is also covered by retention. And then coming to reprocessing analytics. This is the same thing. Backfilling data pipelines. So these are now how traditional queues behave, right? All this topic I'm writing is not a part of traditional queues. Is beyond that. Okay. Again, I talked about cleanup policy. Let's understand this. Cleanup policies. What are the cleanup policies? So there are two primary cleanup policies. Delete policy. So old messages are deleted after retention time expire. Okay. One the delete one. So like we have configured some retention period. Once that period got over, message get deleted automatically. Second one is the compact policy. Compact policy. What is the compact policy? So Kafka keeps only the latest value per key. Means when you send message, it is having some key. So it always keep the latest value of a given key. So this is a compact policy. So log compaction is useful when like use cases like maintaining the current state, caching system, change data capture stream. So what is happening in this? If I talk about suppose CDC, it's a change data pipeline. So what happens in this? Whenever any change is happening in the database side, that change come to some downstream system. Okay. So it always give the latest record. It's not going to give the like last second record. No, whatever last value is getting updated, that it is going to send. And this is the pipeline which is to based on the bin logs or based on the events type, like create, update or delete. This log get generated and pushed to the downstream systems. In the same way, caching system. In caching, what happened? It always cache the latest value. Okay. So this is one example where we can understand what is the cleanup policy. So, and one more thing which is very important, ordering is related to ordering of the message. So topic does not guarantee ordering across the entire topic. Okay, let me make it more clear. One topic was there which is having P0 partition, P1 partition, P2 partition. So what does it say? Ordering in Kafka is not guaranteed across the entire topic. In this topic, suppose it is a T1 topic, so message is coming in this also, in this also, in this also. So ordering cannot be at the topic level. Ordering we provide at the partition level. Remember this. So whatever message that partition 0 is having, a partition 1 is having, in that the ordering will be there. Okay. So since topic is a composed of partition, as we see the diagram, So ordering is local but not global. So ordering is a part of this one, not at the global level. Global means not at the topic level. Okay, so we will understand this when we are going to move in the partitions. Okay, so in the next lecture, when we are going through the partition, we are going to understand this very deep level. Okay, so till now what you understand that a topic is a logical stream of records, a category of events, and configuration is a configurable in retention and cleanup policies, and it is composed of partitions, right? It is persistent, not transient. So topic helps to organize the data. Okay, it's a logical configuration, you can say. Partition help scale it. Now we are ready to move to the most important concept in the Kafka architecture, that is partition. So let's move to the next lecture. Until then, bye.